Okay, the purpose of this video is to demo a few tech tools that you can use to check your contour maps, check your shifts and translations, check work that you're doing for a challenge problem. And I encourage you to use tech tools to help you with this. Some things, when I want you to do them by hand, it will be very explicit instructions. Do this work by hand, show your work. Okay, so we're going to pick a few of these ones that we've looked at recently. We had Z was y minus sine x was one we did recently. Let's see, we've got a couple of these shifts here. Maybe we'll look at this. And we've got this shifted one here. I think, oh yes, we did one more. Z equals x squared y. So we're going to use a tech tool to help us visualize these. And there's several choices, and hope you'll hone in on one this semester that's your favorite. So I'm going to share my screen, and we'll pick tech tool. Okay, so Google's good at graphing 2D, but not so good when we want to do 3D. But there's some really good tools. So let's just Google for Wolfram Alpha. Okay, let's see if we can try just entering x squared y. See some of the syntax, and you'll see some examples. All right, so it's showing us a 3D plot there of what that surface looks like. And then it's also showing us a contour plot, but there's one thing about this contour plot that is not so helpful, right? It has the shading, but it doesn't have the z equals k values labeled on the level curves. And sometimes you can kind of figure out what they would be, but you can see those things that we had drawn on our example a few videos back. This would have been like the z equals -1, this was the z equals -2, -3, actually positive 1, positive 2, positive 3, negatives down here. So you can kind of fill that in. The other thing about this tool is you really can't zoom in or customize too much. And there's our contour lines on the 3D surface. But they'll often tell you that you can use the Pro service and pay for that. As a quick service, you pay for it. Another thing to see is their examples. They talk about by topics, calculus, integrals, derivatives, sequences, products, and applications. Here's vector calculus. Let's see what, maybe we'll have 3D graphs. And they'll often show examples as you're typing in. We'll get to the derivatives in a little bit. Okay. So we're going to come back now and I'm going to show you another tool that's called CalcPlot 3D. So we're just going to Google on that, CalcPlot 3D. This one has a bit more power, also a free tool. And you'll see that these are both cited often in your journals. This one comes with some preloaded examples already in here. So it has z equals, and we don't want anything that complicated. We wanted to look at x squared y. And the neat thing again with this one is you can rotate, you can actually grab it and move it and rotate it. And then hopefully you'll start to see some of those contour, the 3D shape that we saw on the 2D contour map earlier. There's quite a bit you can do here. So let's say I want to add another function. So z is a function of x and y. They're giving us another preloaded one, but let's do one that we looked at before, y minus sine x, which we had said looked like corrugated cardboard. I'm going to turn off by clicking this box here, the one we just did, and now do this one. And it doesn't really look like that, I'm sorry, corrugated roofing. It is laid back, but it doesn't quite have the view that we were thinking. And I think that's because we need to change the range. So let's take a look at maybe from like -5 to 5, -5 to 5, on x and y. Give it a few more grid lines to give it a little more specificity. Let's zoom out. Let's zoom in and zoom out of here. And then we'll be grabbing it, rotating it. Okay, now we're starting to see a little more. Too many grid lines in there. Now we're starting to see those undulations, that waviness, and it is leaning back, right? Laying back on that z-axis. Let me take out a few more of these. Okay. And maybe we'll go from minus 10 to 10, minus 10 to 10, and we'll see even more undulations. So what I'm putting in here is domain values, basically. It's only graphing over that domain. All right, so again, we can grab it and rotate. Now, again, it's starting to look more like that roofing material I was talking about, and it is laid back. Move it all about. Some more things you can do on the gear setting here. You can change the color. Maybe you want it to be a constant color. Your favorite color is red. Maybe go with blue, right, lighten it. Transparency, if you have multiple surfaces there and you want to be able to see through to another one. Let's see. If we turned on this and that at the same time, now you can see both surfaces through each other. We made the roofing sign one transparent a bit. Let's turn that one back off and come back to this first one again. If you click on it, it shows more of the features. And this little graph here, hopefully that reminds you of a contour map, that little picture. And it does say draw contour plot when you hover over it. And so that when we click on that, let's see what can happen. Okay, so we have different settings here. And these C's are what we were calling our K's, constant values. It's just a parameter that we're going to choose. Say start your first level curve value, and maybe we'll start at -2. We're going to increment them in certain sizes. Let's say we do them every 0.5. So we'll start at -2. We'll get one slicing through it. K equals -1.5, K equals -1, K equals -0.5, K equals 0, and so on. We're slicing through. How many do we want? If they want to do 11, that's fine. And when you hit enter, you see that these are the 11 level curve values. That was like our list of level curves from before. K equals 1, K equals 2, K equals 3, K equals 4. That's what they're doing here in this section. Then you hit create plot. And now it's showing you those undulations with the level curve values on the graph. This is the level curve. The one at the bottom here was when K was -2, or what they're calling C, all the way up to K equals 3. You can also hide those if they get too junky on the graph. Hit create plot again and it'll show it without them. I'll show them. And then it also says, if you can see at the top in the green, if you click on this part here, it'll show the 3D view with the level curves on there. So this is kind of neat. Now we can see our laid back corrugated roof and grab it and spin it with the level curves that are actually slices. Z equals K. Remember, Z equals 2 is a horizontal plane. Z equals 3 is a horizontal plane. Z equals 4 is a horizontal plane. They are slicing through that roofing material and creating an intersection. That intersection is then plotted in the XY plane. So that's really cool to be able to visualize both of those on the graph at the same time and to move it all around and see the contours. There's one other neat feature I think on this one. Oh, if you want to see a particular point on the surface where you are, you can grab it in this 2D graph over here and use these slider bars. We'll use those often. You might need them for your challenge problems as well. On the contour plot settings, you can project the contours into the XY plane with another color. So let's just see what's going to happen there. All right, so we got a couple colors here. What's going on? Let's go ahead and see by touching this graph. Now when we see it, we'll see there are slices, the red ones, where the Z equals K slices through the corrugated roofing material, creating these sine curves, these undulations, that are then projected down into the XY plane, creating those green curves. And that is the contour map. So again, you can go back and forth between the contour map, which is a little small scale version shown here, or by clicking on this button, it'll show it just in 2D if you want to see that. So quite a few features, play around, and so the time spent on these will greatly help you with future chapters when we get to derivatives. Okay, let me graph a few more. So that was our first couple, sine y minus sine x and x squared y. And then we want to look at a couple of these shifts. So let's look at the y equals square root of x squared minus z squared, which we were claiming was our cone and we think it's hugging the y-axis. So let's see what happens now. So I'm going to come back to CalcPlot 3D, turn off a couple of these. I'm going to enter a new one, so add to the graph. I want to select. I don't want a z equals this time, I want a y equals. So where is that? Okay, all the way at the bottom, y is a function of x and z. So y equals, and square root, just write sqrt, and then we're going to put in x squared plus z squared. Okay, and we're in the xy plane, there we go. So now we're in the 3D, grab it and see. It must have some transparency on, but again, you can see that it's hugging a cone wrapping around the y-axis. Again, usual features that you can play with to change that. And one more, oh yes, x equals. So the last example we had, turn this guy off, we'll select something else to add to the graph. Again, points, vectors, all these things that you will need eventually, but for now, let's go to the x equals. And the function that we were messing around with, oh, well, the pre-selected one is x equals 1. Let's just go ahead and put that in there. We already knew that was a vertical plane parallel to the YZ plane. But we wanted to look at minus 4 y squared minus 8z squared, which we were saying should be like an elliptic paraboloid around the negative x-axis. So let's see. Is an elliptic paraboloid around the negative x-axis. Grab it. Oh yeah, there's the negative x-axis. It's definitely not circular. It does look like, yeah, from this angle now you can start to see that it is elliptical. Here's the positive x-axis back there. So we can see that we didn't need a contour map. We didn't really have to do any analysis. We just had to recognize patterns that we saw. And CalcPlot 3D would help us there. Let's see, one last thing I think from this. Not a tech tool, this is really low tech, but we talked about our Pac-Man cone. And so I did a little upgrade to my corner of the room. I don't know if you can see this here. Corner of my room, I upgraded and added some Post-it tags. I don't know if you can get those in there in the view. Oh, I should stop sharing the screen, might help first of all. Right. Oh, there we are. I added my Post-it notes to the corner, and so I now know with this Pac-Man cone, this would be a cone through the negative, coming out from the origin, but going along the negative x-axis, which is through the room. This would be the positive x-axis. Okay, so that is I think the last topic for chapter 1. Enjoy.